So to end this section, we're going to look at a couple example problems now that we've kind of developed the theory and some understanding of why the formulas work the way they do. So example 6.5.1, finding probabilities for sample means. So the birth weight of boy babies of European descent who were delivered at 40 weeks is normally distributed with a mean of 3,687.6 grams. So again, this is for a distribution, so that's mu sub x, and a standard deviation of 410.5 grams. Again, this is for a probability distribution, so we're going to use the parameter sigma sub x for that. So suppose there were 9 European descent babies born on a given day. So 9 is our sample size, so there's little n. And the mean birth weight is calculated. So again, this is for those 9 babies, so that's our x bar. Alright, so kind of just reading through the paragraph and just picking out all of the symbol information that we need. So part A says to identify the individual, the random variable x in the context of this problem, and then we're also going to list the given information with the correct symbols because we're going to need it as we start making these computations. So an individual is one of something. So again, this is going to be a randomly selected boy baby of European descent. And so our random variable x for quantitative data for this particular class is going to be of the form the measurement of a randomly selected individual. And in this case, the measurement we looked at was birth weight. So this is going to be birth weight of a randomly selected boy baby of European descent. And our givens here, we're just going to list these. We kind of outlined them as we read through the paragraph there, but mu sub x is going to be 3,687.6 grams, and sigma sub x is going to be 410.5 grams. And then I'm going to add in here, because we'll need to know that we have a normal population to be able to use normal CDF and inverse norm. And then the other piece of information we were given was that little n was 9. Okay. So part B says to identify the random variable x bar in the context of this problem. Okay, so x bar is our symbol for sample mean. So the wording for that in general is going to be the mean measurement of n randomly selected individuals. So in this case, that's going to be the mean birth weight of 9 randomly selected boy babies of European descent. Alright, so then part C, we're asked what is the mean of the sampling distribution of the mean? So that is a lot of words for the symbol mu sub x bar. Okay. And from the previous page, we know mu sub x bar, that value is the same as the value of mu sub x, and that value we were given as 3,687.6 grams. Part D, we're asked for the standard deviation of the sampling distribution of the mean. So again, that is a lot of words for sigma sub x bar. And again, from the previous page, the formula to compute that is sigma sub x over the square root of n. So we're going to get 410.5 over the square root of 9. So that's going to come out to be about, rounded off, 136.8 grams. All right, so part E now says what is the distribution of the sampling distribution of the mean. So in this case, our original random variable has a normal distribution, so the sampling distribution of the mean also has a normal distribution, regardless of the sample size. So in this case, we were given the random variable x. We know it has a normal distribution where mu sub x was 3687.6 grams, and sigma was 410.5 grams. And from that, that implies that the random variable x is going to have a normal distribution. That distribution will be centered in the same place as the original distribution. So mu sub x bar is going to be 3,687.6 grams, but the standard deviation is going to be smaller. So sigma sub x bar is roughly 136.8 grams, or exactly it was 410.5 over the square root of 9 grams before we rounded it off. Okay, so in this case, our initial population was normal, so we did not need a sample size of n at least 30. Okay, that's for when we start with something that's not normal to begin with. So again, original population is normal, random variable x bar will be normal regardless of the sample size.